And here we're going to be talking about limit definition of a derivative. And again, this is something that the College Board always tests on the AP test. Okay, so we learned in the other lesson, d dx of f of x is our derivative, which can also be written as f prime of x. Remember, this was Leibniz, this is Newtonian, and it's defined to be the limit if delta x goes to 0 of function of x plus delta x minus f of x over delta x. If this looks familiar, it is. You've already done this for some functions. You found the derivative, and I fooled you into thinking you hadn't done it. So let's deal with some examples of this. We want to find the derivative of f of x equals 2x squared plus x minus 1. So we're going to use our definition, limit as delta x goes to 0. And this is usually one of the questions they like to put on the non-calculator part because it really doesn't help you much to have one. And it's f of x plus delta x minus f of x over delta x. And now I plug in. So I'm going to have 2 times x plus delta x squared plus x plus delta x. Remember, everywhere I've got an x, I'm putting this in, minus 1. And then it's minus my original function. So 2x squared plus x minus 1. And this whole beast is over delta x. So again, we come in, I'm going to expand this. So we're going to have 2 times x squared plus 2x delta x plus delta x squared plus x plus delta x minus 1 minus 2x squared minus x plus 1. I'm distributing my negative in. And all of this is going to be over delta x, and we're finding the limit. I just don't want to write it. Okay, now I'm going to go ahead and bring my 2 in. So that's going to give me 2x squared plus 4x delta x plus 2 delta x squared plus x plus delta x minus 1 minus 2x squared minus x plus 1. So now I look for terms that can cancel out, and we always look first for the terms without delta x. Oh yeah, and all of this obviously is over delta x. So I've got a 2x squared, and sure enough, I've got a negative 2x squared. They go away. That won't, that won't. Okay, here's one without a delta x, and sure enough, I've got a minus delta x. I got a negative 1 and a plus 1. So those go away. And if you do it right, and this is a nice check at the beginning, these should all, everything that does not have a delta x in it should go away. So we're going to end up with 4x delta x plus 2 delta x squared plus delta x all over delta x. So that big mess is reduced quite a bit. I'm going to factor delta x out of the top. I've got it in all 3 terms. and you should be able to factor a delta x out of all terms. Since we've dropped out everything that doesn't have a delta x, plus 2 delta x plus 1 all over delta x. Okay, now I've got this times this thing. Okay, now normally I told you not to do it when you've got a plus, but this is times this divided by this, so those divide out to 1. So now I'm left with the limit as delta x goes to 0, and I brought it all the way down from up here, because here's the point where it's going to come in. 4x plus 2 delta x, it's going to go to 0, plus 1. So my derivative now is 4x plus 1, and that is your derivative. Okay, so things to remember. And I do mean remember, and not just for a few days. The derivative is the slope of tangent line. This is an important concept. Remember we were talking about the tangent line problem, where they solved it? It's a derivative. Okay, also, the order of the derivative, which you remember is the highest exponent, of polynomials, because this will be different for other things, is 1 less an original function. Okay. So the other thing then you're going to have to know is how to graph a derivative. And this is another thing they love to do because it's a good indication of your grasp of what a derivative is from the graph of the function. Not the equation, but the function. You aren't given an equation. Yeah, we're mean that way. Okay. I've got an asymptote here. Okay, I'm going to break this thing down into some points that are important. Obviously, where we start, let's call that point A. You notice up here, and we need to graph the derivative, which is the slope of a tangent line. Okay, so you've got a bunch of little tangent lines here. Notice here your tangent line is 0. Those are always important to find. We'll call that point B. I've got another one here. Let's call that point C. And then obviously our asymptote is something that's of interest to it. It's point D. So let's take a look then, and we need to graph the derivative. So this is f of x, x. You want to graph the derivative of f prime of x over x. Well, bummer. You don't have an equation. What you're going to have to do is look at what the tangent line is doing. Okay, what you notice here is this function is increasing, which means our slopes are positive. Here I've got a slope probably around 1, more or less. Although what it actually is doesn't matter. And you know not only my slopes are positive, but they're decreasing. The actual rate of the slopes are decreasing themselves. And I know at point B, my slope is 0, the tangent line is horizontal. So I'm actually going to put a point here at B, because I know it's got to be 0. And I've got another one here at C, because it's also 0 here. So I know A, I start off with a slope of something like this, and I know that I am decreasing down to 0. It's going to look something like this. I'm going to come here. Now you notice here, my slopes are negative. It's a decreasing function. Slopes of my tangent line are all negative. Not only that, but they tend to they're going to increase to this point, and then they're going to decrease down to 0. So what I'm going to have is, going from 0, I'm going to go negative slope down to some point about here, at which point it's going to come back to 0 at C. Okay, now at this point, you notice they're all positive. So we're going to be going up, because these are positive slopes and these are negative slopes. Not only that, but I notice at D it's going to infinity, which means my slope is going to go to infinity. So I'm going to increase out here, and then I'm going to go like that. And that is what the graph of the derivative looks like. And the way you interpret it is, at this point, my slopes are positive, so the function is increasing, but my slopes are getting less and less shallow. Okay, so it's going to be concave down until I get to a point B here where my slope is 0. My graph goes flat. Then it goes negative, and it goes big negatives for a while, then it comes back, and I go back to C. It's going to be 0 again. And then I'm going to go to positive slope, and the slopes increase on unbounded. And this is what you're going to have to be doing for this next unit, is graphing a function or derivative from a function. All right, and remember, all you're doing is you're looking at the slopes of these little tangent lines. So just draw a bunch of them if it helps you. And a really important thing that'll make the job a lot easier, is to look where your slope is 0, where it becomes flat, like here and here, and mark those points.